Hello everyone, welcome back in the course of higher surveying, and today we are in the new module, hydrographic survey. This is module 9 or second last module of the course. Okay, so what about the hydrographic survey? Why do you want to learn the hydrographic survey? First of all, I would like to tell you, you might have heard two terms, hydrographic survey and bathymetric survey. Okay, in case of hydrographic survey, we collect the information of the seabed or the topography underwater surface. Okay, so we are collecting 3D information for that surface which is under the water. At the same time, if I collect some additional information, for example, the type of vegetation on the seabed or the material available there, or any other information which is relevant to maybe geophysical survey or which is relevant to any other aspect of our exploration, we call it bathymetric survey. So bathymetric survey contains the hydrographic survey also. Fine. So in this course, this module is about only hydrographic surveys. Fine. So let us go ahead. You might be surprised that why do we need the hydrographic survey, where we collect the 3D information on the surface of the seabed, which is under the water or the river bed. Okay. Let me tell you one simple example, that we are talking about the river navigation now, because most of the settlements and the cities are developed on the banks of the river. For example, Ganga, Brahmaputra or Yamuna. Maybe Krishna and Godavari are also good example in South India. Fine. So the issue is that now we want to look for methods where we can use the rivers in order to transport people or in order to transport some material. Well, for that purpose, I need to have some place what we call as jetty or the bank, where a ship can be parked or a river vessel can be parked, or the vessel or boat can be parked, and from that place it will start rowing in the river, and it needs to navigate through the path which has enough depth of water to support the buoyancy of the vessel, right? And that's the reason we are looking for a 3D surface data of the riverbed or seabed. A similar example is good enough to explain you why do we need the seabed 3D data, because we want to navigate from one country to another country, or maybe one sea coast to another sea coast across the ocean. Well, it is very much important because it will allow us to transport a heavy material using vessels or ships. Fine. I think that is a good reason for you to understand that we need the hydrographic surveys. Okay. So let us go ahead in this lecture. So this lecture, it is based on the fundamental concepts of hydrographic survey. Moreover, we have total 3 lectures in this module on hydrographic survey. So the first lecture is about fundamental concepts of hydrographic survey, which we are going to address today. Fine. So these are the books. Again, few of the books are very expensive. So once you join some library or once you join some institute library in order to avail such books and make the notes. But again, I say that these 3 lectures of this module are sufficient enough to create good knowledge for you. However, if you need more knowledge, you should refer these books. Okay, so let me introduce this hydrographic survey formally. So it is the branch of surveying which deals with any body of still or running water such as lake, harbor, stream or river, or you can also include sea. So then it is the science of study of underwater topography. Well, that we have already said. Okay, so in this hydrographic survey, we map the features like shape of the coastline. We also find out what are the locations of possible obstructions and the physical features of water bodies, and then we try to map the shape of the sea floor. Okay. The purpose of doing this, that is, we want to ensure that safe and efficient movement of offshore transportation system, and that's the purpose we have already discussed slightly. But now you may be little surprised that why do we want to do the measurement of the complete river or complete seabed? Okay, so let me explain you the reason. Okay, you might have heard that there is a tides in the sea, okay, and it is because of the interaction with the interaction of Earth's surface with Moon and Sun? Well, that's the kind of understanding we have already developed from our 6th or 7th standard. Okay, now the idea here is, because of the tide, what happens? Water level rises, right? And because of that, there is a change in the water level. Moreover, such tide also creates some change in the shape of the underwater bodies. For example, there is some unconsolidated material located in the sea that will be shifted because of this water level rise, or maybe downing of the, or maybe the lowering of the water level. And moreover, we need to understand that if water level is high, how can we take advantage of that? At the same time, if water level is low, we should suspend some of the activities. But for suspending some of the activities like shipping or rowing a boat, we should know what is the water depth available at low tide, right? Now you got the idea that why do we need the hydrographic survey, fine, and what should be the time interval. So we should do it very frequently or less frequently or at yearly basis also. So let us try to understand those things with the fundamental concept of the tide, that why tides are visible or why do we experience the tides. Now we are showing the 3 planets, Sun, Moon and Earth. So Earth is shown with this radius RE, and there is a Moon and the Sun. Okay. So because of the attraction force between Moon and Earth and between Sun and Earth, we have the tides. So let us try to understand what does it mean. So let us say this is the distance between Sun and Earth, and this is the distance between Moon and Earth. So these distances are indicated by ds and dm. Now for the Earth, let's say at this center point of Earth, if I write the force that is acting between Moon and Earth, I can write like this. Remember the rule of the Newton's first law of gravitation, I can write here. So let us say mass of the Moon and then mass of the Earth divided by dm square. Here if I assume that mass of the, we are talking about the mass, a unit mass here on the Earth, then I can write the acceleration light at the center of the Earth as gmm divided by dm square. Okay. In a similar fashion, I can write the acceleration for the Sun. Let us say at the center of the Earth, the acceleration caused by the mass of the Sun, and the distance between the Sun and Earth, it is this. Okay, we agree with this idea? Well, now you can observe very easily, if I talk about the Sun and if I talk about the Moon and Earth interaction, there is a point here, fine, and there is a point here. This point, for example, if I call it point number 1, it is called sublunar point, and corresponding to this sublunar point, this point which is opposite by 180 degree longitude, it is my antipode or antipodal point, right. Now you can see that point 1 is much closer to the Moon compared to the point 2, which is farthest from the Moon. And if I just say there is a center C here, so center, compared to the center, the point 1 should have higher acceleration and point 2 should have lower acceleration, fine. So can I write the acceleration at point 1, which is sublunar point, as my gmm divided by dm, which is center to center distance, minus radius of the Earth square. I hope you agree with that. And similarly, I can write here A2 is equal to gmm divided by dm plus re square. I hope you agree with that, these two formulas at least. Fine. Similarly, I can write the same formulas like A1 and A2. So if I declare that this point is A1, the point number 1, or call it 1 dash, and call it the point 2 dash here, which is subsolar point here, and the antipodal point, that is 2 dash, corresponding to this subsolar point, fine. Okay, let us say write 1 dash equal to g m of sun and then ds minus re square, and similarly if I write a 2 dash equal to g m mass of sun, then ds minus plus re square, like this. Okay, so we know that these are the acceleration values a1, a2, and they are the vectors also, fine, and they are basically working on the points, different points on the surface of the earth. Okay, now what is the problem here, or what is the conclusion here? Okay, so if I try to draw these acceleration values of AC, then AC will be towards the moon like this at each and every point, because I can see that earth is my point mass, fine. Okay, and so the acceleration AC is same at each and every point as if earth is a point mass, fine. Yeah, I hope you agree with that. Okay, at the same time now the force acting because of the moon, they are working on the surface here. So here at point 1, that is my AC and that is my A1, right. This is my AC and this is point A1. Similarly, at any other point I can mark this direction towards the moon. That means this is my AC here, and if I draw the direction towards the moon, this point, this is my A, right. So basically this is direction now. So we know that there are some differential forces are acting on the surface of earth. One, because of the center to center distance between moon and earth, and another is on the surface of the earth because of the moon gravitation. That means there are two forces working on the surface of the earth. One is because of the gravity of the earth and one is because of the gravity of the moon. Now, what is the consequence of that? Okay, let me tell you one thing, that same thing is happening for sun also. Since I am not marking it here, it does not mean that it is not happening. It is happening with sun and earth interaction also. That means a point on the surface of the earth is attracted by moon, as well as it is also attracted by the gravity of the earth. Well, so let us go ahead with this idea. Okay, so this is a given here situation. Now, if I, for the moon, if I want to find out what is the differential force at a point, so A1 minus AC, let us say at this point, and what about this point, and let us try to make it. So it is GMM 1 upon d S minus RE square minus 1 upon d, I am sorry, it should be dm square, fine. Now you can find out that this one, if you take the multiplication and everything, you will get a expression where dm cube will be there, and this is the expression you will get. Okay, at the same time, if you take A2 minus AC for the moon only, we are talking about, again you can write GMM, then 1 upon dm plus RE whole square minus 1 upon dm square. So here we will get minus 2 times GMM RE divided by dm cube here. Okay, the similar relationship I can also write for the sun, where this mass will be replaced by the mass of the sun and this distance will be replaced by the ds. Okay, here we have taken one approximation that the radius of earth, the ratio of radius of earth to the distance dm is approximately 0, and try to derive this one yourself, you will get this one, right. Similarly, here if we derive such formulas, we have to take an assumption that the radius of earth, the ratio of radius of earth to the distance between sun and earth center to center is approximately 0, because this radius of earth is very small compared to this distance, and similarly here also. Okay. Now, what are the forces for tide generation? How tide is generated? We have learned that what are the forces working on this one. Okay. Now, you can imagine that there are some forces on the surface of earth, let us say because of the moon. Okay. So, here there is a force here working like AC at each and every point. Okay. And at the same time, if there is a moon here, then what will happen? There will force AC, that is because of the gravity, the center to center interaction between moon and the earth. So, this is my center C, but at the same time there is another force working here called A1, or I call it AM now. Fine. So, direction of AM at each point is towards the towards the moon. So, like this, and like this. Okay. What about the AC? AC is like this. Here at this point, if I draw, AC is like this, and this is my AM, and so on and so forth. Now, here AM will be like this. So, you can see here AC here, and AM is this one. So, this is my AC. Well, the direction vectors are not showing in proportion to the force value, but just their indications. Now, if I just make a vector sum, I can see here that this is the, for example, at any point one is AC here, okay, and there is one AM here. So, the resultant force, since it is higher force, if I just consider the top half, let us say it is my equator, and moon is like this, for example, or don't say, okay. So, so this is my resulting force called FD or AD. The acceleration is AD here, fine. Okay. Now, you can understand that it is the vector sum, this force is vector sum of two forces working here, or two differential forces, right. So, this force is causing the tide. How? We will see now, but before that, so if I resolve this force FD, which is working in this direction, fine, into the horizontal and vertical component. So, vertical component will be like this, which is perpendicular to the surface of earth, and one force will be like this, which is tangential to the surface of the earth at this point, like this, fine. So, this is my FH. Okay. So, the importance of this FH and FV is very, very critical in terms if I want to understand the tides. Okay. Now, first of all, we should understand that since at this point this is my gravity direction and force is working like this, okay, what about this force? And this force is called, FH is called traction force or tractive force. Fine. So, if I just go ahead explain this thing here, we have already explained these two things, right. So, that differential forces at the sub-solar point and closer to the sun, and similarly away from the sun, antipodal point, fine. These are the acceleration acting here, okay. Similarly, for the moon we have written like this. So, you can check yourself these derivations, okay. Now, we have said that there is an attractive force working on the surface of the earth. Okay. What is this attractive force? Basically, the vertical force which is working perpendicular to the surface of earth at that point is not going to cause any tide. It can change something, but it is not going to cause any tide. Okay. Now, if you look at the forces which are horizontal or which are tangential to the surface of the earth on water, what will happen? They will bring the water like this. Why? Because you can see here on the screen that this is the force. Suppose this is the moon here on this direction. What will happen? This is the horizontal force here. This is the horizontal force here. This is your horizontal force here and horizontal force here, right. So, we have resolved this FD into two values. Here this is my FD, this force, and we have resolved it, and here there is only FD working in this direction here FD. So now you see there is FD here, this force we have resolved into two forces, one is FH and one is FV. So you can see here that the half part of the earth where water is located, the tractive force or the F horizontal, it is bringing the water towards the one point and which is closer to the moon. Fine, I hope you agree with that. And in order to make the equilibrium again on the surface of earth, what is happening? The 50% of the water in the other part which is opposite to the moon, it is going in other direction. Okay, so there is a point which is closer to the moon and there is a point which is exactly opposite to the moon on the surface of earth. So 2 points here is now water is accumulating at 2 points. Fine, you can see here that tractive forces are bringing the water here, and as a result what happens because of these tractive forces, a sea level will experience a rise in the water level because water is brought from the other places to one place. Okay, the same thing happen. So this kind of tides are happening here and water level is rising at this point which is very close to the moon or which is located towards the moon at this moment. Okay, what about this point? Here you can also see that if I divide in half the earth, this part is also making these horizontal forces and this is also creating a tide or again the rise in the water level of the sea or any river also, because if river is quite big, that will happen that its area is quite big like sea, that will also be affected by the moon. Now you can see very wonderful effect here, or you can see very wonderful phenomena here, that is on the 2 points on the surface of earth, tides are occurring and high tides are occurring. So one point is where which is very close to the moon or towards the moon on surface of, so one point on the surface of earth which is very close to the moon or towards the moon, and one point which is exactly opposite of my first point. So one is sublunar point and another is antipodal point. Similar thing happen with the sun also, but there is some issue here. The small critical analysis has to be done, that who is more stronger or who is stronger, the force of sun or the force of the moon. Fine. Here you can see that water is accumulating over this place and water is accumulating over this place, and because of that both these places are experiencing the tides because of the presence of moon or maybe some other planet like sun. But as I told, we have to see now that which force is stronger, that means the force of the moon or force of the sun. So let us look into this thing. Moreover, we can see here that tractive force is although 0 at the antipodal and sublunar points, but they are responsible for creating the tides because water is accumulated although force is 0. Fine. And now what should be the height of the water rise? Okay, that water is rise or the water rises to a level where the force of the moon on the water and the force of the gravity of earth are same. That means the water surface becomes in equilibrium after creating the tide. Fine. I hope you agree with that idea now. So let us go ahead, and here we can see that tractive forces are maximum at alpha equal to 45 degrees, where alpha is shown with respect to center of earth here, and so this is somewhere moon is here. Okay, if the higher tractive forces are there, although they are in equilibrium, but it will create higher tides. Okay, so now as we told that which force is stronger on the earth, so let us look into the ratio of the force. So if you take the ratio of the forces, let us say this is the force created by the sun and this is the force or acceleration created by the moon. If you take the ratio, you will get this expression, right? I can see that the force created by sun is proportional to the mass of the sun, but inversely proportional to the cube of the distance, and similarly for the moon. And if I take this data which is listed here, right, about the radius of the earth and about the mass of the moon and sun here, so not this data, so this data, if I use this data and then I use this data, the distance, that is my ds and that is my dm. Fine. So if I put this here, what will happen? I will get a ratio 0.46. You can try it yourself. Okay, so what does it convey? It is conveying very important aspect, that the force exerted by the moon, it is more than 2 times of the force exerted by the sun, and that is why we say that tides are basically caused by the moon. right? Yes, there is reality that sun also contributes that, but tides are always caused by the major forces of the tide is because of the moon. Fine. One more aspect I would like to tell you here, that if you go back here, so water is accumulating here under the influence of tide and accumulating here. But what about this point? Water has been withdrawn from here towards this side and this side. So these are the points of the low tide. Similarly, this point is point of low tide. Here point of high tide, and here also we have high tide, right. So it is my sublunar point and it is antipodal point. Well, what about the forces here? It is zero attractive forces, but still we have experiencing the high tide at both places. Fine. So now you understand that there is a variation of the water surface of sea because of the moon's attraction. Okay, now we can see here that the moon rotates at its own axis in 24 hours and 50 minutes, and this is the solar hours, that is, we can say almost 5 hours. So what happens? Let us assume that moon is at fixed and earth is rotating like this. So I can see here that because of the rotation of the earth like this, at one place, the one place on the surface of earth will face the moon 2 times in a day. Fine. Or I can say 2 times in this 24 hours and 50 minutes. Why? Because let us say there are 1 point here, 2 point here. So now earth, if earth rotates, let us say points are like this, 1 point here. So if earth rotates like this, so after 12 hours and 25 minutes, this position will be here, which is away from the moon, and this position will be here. 12 hours and 50 minutes, this point will be coming here and it will be like this. Fine. So during these 2 times I can see at when the moon was here and this point was here, there was high tide here and high tide here. After 12 hours 25 minutes, again situation is same, high tide is again here and high tide is also here. So in one day we experiences 2 high tides at a place. Similarly, when this point is at 90 degree to the moon, there is low tide and low tide. Okay, when this becomes like that, low tide and low tide. So we experience 2 high tides as well as 2 low tides in one day or one tidal day, and tidal day is nothing but 24 hours 50 minutes. Okay, so that is explained here, but you can see here that there is a high water here and there is a low water here. Fine. Okay, and this is the moon's position. So it is high tide here, I can say high water. Okay, so now we also observe the variations in the tide. Why do we observe? Fine. Let us see, there is a moon and we have already resolved this problem that there is high tide here and high tide here. Okay, what if moon is like this? Fine. What will happen? Although this is my north-south axis here and equator is like this point will experience high tide and this point will experience high tide, and these points are low tides points here, you can see, and this is, let us say, high tide and high tide here. Fine. Now we can observe the same situation here. I am marking the equator by x dash, and moon is, let us say, here somewhere, and this meridian moon is there. What will happen? This is my high tide here. Fine. And this is the high tide here. Okay. What about the point Z? If you see that point Z is having high tide, but the point Z dash is having, which is at the same latitude. You see, this is my parallel of latitude here. And Z and Z dash both are located at the same parallel of latitude. What will happen here? This is the tide level, which is quite low compared to this level. Okay, fine. Now you can understand that why do we have different tides within a day also. Okay, because as points are away from the equator and moon is not located at the equator, it will create different tide levels at the same parallel of latitude. Similarly, if you look at the Y position here, which is again on the same parallel of latitude, this is the tide level and this is the tide level, right. So we know that Y and Y dash, when they will be having high tide in a day, but at the same time between high tide and low tide they will be having different tide levels. Okay. So what about the X position, which is at equator? You can see here with respect to moon, with respect to this point, this has same tide, and with respect to this point it has same tide. So at equator the tide levels are same, but as we go away from equator, for any given position of the moon we can experience the different level of the tides at the same parallel of latitude, because one point which is near to the antipodal or sublunar point will have higher tide, but the point which is quite away from the antipodal or sublunar point will have low tide. So that's the key here, that we also see the variation in the tide levels. Okay, now what about the frequency of the tides? We have to understand the variation of the tide, variations in the tide level. We have also understand that there is a high tide and there is a low tide, and across the day we will feel 2 high tides and 2 low tides. Okay, but we also know that moon revolves or orbits around the earth. So what's the effect of that? We'll have the tides. Remember that there is a ellipticity in the orbit of the moon. As a result, moon will be sometimes closer to the earth, sometimes little farther to the earth. And what we have said, ds and dm, they are the average distances. Fine, this is not the real distances, and because of that, this variation of the average distance and the real distance, we will have variation in the tides across the year also. Fine. Okay, so we'll see this thing now. So what are the factors that affect the tides? I have written on this slide, so you can read it yourself and you can confirm this thing from the previous slide. Fine. Now there are 2 terms associated here, that is the spring tide. Okay, we have seen that moon and the sun both are exerting force on the surface of the earth, and moon is more effective because the distance and the mass combination. Distance is much closer to the earth, and as a result moon is more effective. However, what if both of the moon's and the sun's force are exerting in the same direction on the surface of earth, and we will experience the highest tides, and that is shown here in this picture on the slide. This position is called new moon, when it is sun and moon are aligned in one line and they are basically above on this meridian of this point, and here we can see the high tides here. Similarly, as we know, there will be high tide here also, and there will be lowest tide here also. Fine. Okay, and this phenomena is called the spring tide. Okay, so it occurs at the new moon and full moon, and attractive forces or high tides are the common phenomena. One more thing I would like to write here, that I can see that the highest of the high tides are observed. Okay, fine. There is another phenomena called neap tide, where sun and moon are at 90 degrees to each other with respect to the earth. What will happen? As we know that moon is more effective, so there will be high tide here and there will be high tide here, right? But you can see here that sun is less effective, so we have low tide here and low tide here. But you can see one more thing, since both sun and moon are trying to attract the water surface in completely opposite direction or at 90 degree. Fine. So one is this vertical direction, one is horizontal direction on the screen. Now what will happen? We will experience the high tides, no doubt, in the direction of moon. We will experience the high tides towards the moon, and we will experience the low tides towards the sun. However, the amount of the high tide or the height of the tide in the direction of moon will be much less than the highest tides or the spring tide. And I can see here one thing, that this tide is although high tide, but it is the lowest of the high tides, right? So I can see the tides are lower than the average here. Fine. Now you can understand what is the meaning. Meaning here is we see that it is the lowest of the high tides, and that is called neap tide here. Fine. So now we have understood why tides are coming, why the water level is raising, why there is a variation in the tide level, when we have maximum tide, when we have minimum tide, okay, or the lowest tide or highest tide. Fine. Now at this stage we should also know what is the frequency of the tide at a place on surface of Earth. So here you can read it. The position of the moon at third and first quarter are creating the neap tides. Okay, there is another phenomena called priming and lagging. Okay, when the position of the moon is from the lowest tide towards the high tide, this is called the priming, and the vice versa, that is the position of the moon from the high tide to low tide is called lagging. So like these are the fixed terms here. Okay, you can now what is the frequency of the tides? Okay, so now we can see that tidal potential which are causing the tides are modeled by series of harmonic function, because they are basically varying like sinusoidal form, or we can say some kind of periodic functions, the tidal forces, and they are creating the tides like that. Now we divide the harmonic coefficients into the three categories. One is semi-diurnal, that means 2 high and 2 low tides in each tidal day. Then diurnal, that is daily, that single high and single low tides in each tidal day. Then we have long period. Long period means fortnightly, monthly, semi-annually, that is 6 months. Then 8.8 years, because eccentricity of the moon's orbit. Sometimes moon is closer, sometimes moon is away from the earth in its orbit. So then we have 18.6 years or 19 years, if you remember the figure. That is because of the orbiting of the moon around the earth. Similarly, earth also revolves around the sun over a period of 20.9 years. That means the point will be exactly at the same position with respect to sun after 20.9 years or 21 years. Fine. So, but as we know that effect of the sun is much less than the moon, that is why we always prefer a period of 19 years for the observation of the tides. That means we create the MSL by observing the variation of the tides over a 19 years period at a place or at a sea coast, right. So I hope that you got the idea why do we having lot of variations, or why do we go for some kind of technical analysis for the tides. Okay, so now let's understand what is the necessity of the hydrographic surveys. Well, we have said that tide is there and tide is going to increase the water level, tide is going to decrease the water level than the average value. Okay, but I want to measure the depth at each and every location, at each and every moment instant. So what's the reason? The reason is that we want to expand the offshore engineering and shipping industry, and if I construct some structure or some sea coast, I need to have this data of hydrographic survey, that what is the material available or what is the material has to be cut from the available sea surface, right. Then we have to locate resources like oil and gas wells in the sea offshore sites. For that also I need to bring my boat or the staff members to that place for the drilling, and for that purpose we also need this data of hydrographic survey. Okay. Then we also see the supporting material has to be provided. Sea and river navigation we already talked about, and then recreational purposes. What are the recreations? If you go to some kind of place like Goa, you will have near the sea, what will happen? There are some scooters are moving in the water surface and they are available on rent. For such kind of recreational facility also, we have to have the information about the tide as well as information about the 3D data of the surface bed of the water body. So what are the objectives here? First of all, I want to measure the tides, then I want to determine what are the shorelines, then what is the wet depth, what is the current velocity and speed and direction of current in case of rivers, and what is the amount of flow. Fine, because for the river navigation these factors are very important. And okay, what are the scouring and silting, then for the rivers, okay, then shoals are the submerged ridges and banks of unconsolidated material. That means they keep on moving with the flow of water. That means when there is high tide in the sea, what will happen? Because of the traction forces or tractive forces are bringing the water at one place and again they are withdrawing the water. Because of that movement, because of that there will be a movement of the shoals. So I want to determine those. Okay, then what are the places where light rocks and bayous are there, right? So now how to plan the hydrographic surveys? First of all, we go for the reconnaissance survey. Then we also should know what is the area of the survey, which is like say some kilometer square, some kind of few kilometer to kilometer, what is that? And then platforms available, like we have ships, aircraft or vessels. Then whether it's a short term or long term survey, that means long term means I will collect the data after a certain period, which is quite long, and short term means I am frequently taking the data. Then other limiting factors like budgets, political reasons, geographic or operational constraints and logistics. These all factors we should consider in planning part of the hydrographic survey. Okay, now in case of hydrographic survey, as we told, I want to observe the 3D information, or I want to measure the 3D information. Fine. The thing is that how to obtain that? So we have to establish the control surveys. So first is vertical control. So what is vertical control? We have from the topographic data some data available about the benchmarks. So using those benchmarks, we bring the control stations very close to the sea surface, or what we call shoreline. We'll see all these terminologies in the next lecture, but right now try to understand what's the concept here. Okay, then using those benchmarks, and we establish the levels of the seabed. Fine. So that is my vertical control. What about the horizontal control? Similar to the vertical control, I bring the points of the horizontal control, that is the x and y position from the topographic survey to the near to the sea coast, and there also we establish some control stations, and this process is called the horizontal control. And using this horizontal control, we determine what is the horizontal position of the point which is lying under the water, but we measure it from the surface of the water. Okay, now we can understand that because the planimetric position xy is measured on the surface of the earth, and at the same time we measure the depth of the water surface, right, by some mechanism. So we need to ideally separate the two surveys, but still it is not a pseudo survey. No, it is not a pseudo survey, because we are measuring x, y and z at the same time. Moreover, we are considering the curvature of the earth also, and we are no more projecting the earth on the plane projection. Fine. So it is not a pseudo 3D survey, it is a perfect 3D survey, but the thing is that we measure the xy on the water surface. Also we measure the depth of the seabed on the water surface, but we need to have the different instruments for that purpose, because I cannot measure the depth of the water using the conventional instrument like theodolite, total station and so on. I need to have some different instrument, and for that purpose we separate the planimetric survey and the vertical survey in case of hydrography. Fine. I hope that you got the idea here. So let us see that some more terms. So once we conduct a survey, what do we do? Basically we take a vessel. Now we row the vessel along a straight line. Okay. During that straight line we observe the points at regular interval, a regular time interval or regular distance interval, whatever. Fine. So this is shown here. Now you can see here, because of the variation in the current velocity or variation in the boat, we are having lines which are not straight, but still we are trying to maintain them. So now these are the data points I have collected at a regular interval on each line, and these are the lines or the track of the vessel or boat. Fine. You can see here that the distance between the two lines here, I can say that average distance. So that's a good way to mark here. This is my line spacing. This is the line spacing. This is the line spacing, and so on, right? So line spacing decides the density of the data points. At the same time, we'll see in coming lectures that line spacing decides the time interval to cover the whole area. That means the duration of my survey. Rather, indirectly it is giving me the cost of my survey. The higher the data density, higher the cost. Higher the data acquisition time, higher the cost. Fine. So what are the factors that affect this line spacing? One is the scale of the survey, as I told. If I have higher density of data points or higher accuracy of the data points, what will happen? Definitely my line spacing should be smaller. Okay, what about the orientation of the shorelines in the area? Right now we assume that the shoreline is like this, and that's why we are starting either from this point, this is my starting point and this is my end point here, right? So we are starting from shoreline with the boat here, and we are finishing our survey here at end point. So this orientation of the shoreline, that also decides the data space or the line spacing. Okay. Now the DTM, okay, the efficiency of the DTM is for the correct contouring. Now so DTM requires the sufficient data density to draw the correct contours. That means I need to have more amount of data, at the same time I need to have more accurate data. That means each and every point should be more accurate for higher contour interval. Fine. Here these are cross check lines, or they are sometimes called tie lines. Okay, we can see here these lines are the cross check lines. Here we can see that these are my main survey lines that we have already discussed in last slide. Okay. Then after doing this survey and after collecting the points on these black dots, what do? We try to validate our work by collecting some points on these lines which are perpendicular to the survey lines. Fine. And this validate my work here. Similarly, if my survey lines are vertical on the screen, these are my cross lines. So I am collecting data over there in order to validate my work. Okay. Similarly, if I have two type of survey lines, horizontal, vertical, so I will have two type of my cross lines also, like this, right? You got the idea that how do we validate our work? So what are the equipments required? Okay, buoys and shore signals. That means there are some signals which are floating in the water and where we measure our XY position as well as depth. So these are called buoys, and here it is indicated. Okay, for the angle measurement we have theodolite. For the total station, also nowadays it is used because we can measure the distance as well as angle with the total station. Now sounding poles and the lead lines. Well, we will look into this thing. What are the lead lines and sounding pole? Basically, these two instruments are used in order to measure the depth of the water surface or the water bed. And then we have sounding equipments. In sounding equipment, these are my sounding equipment, lead line and the sounding pole. And also we have sounding equipment like echo sounders. We will see all these things as we proceed in this lecture. So first, the lead line method, which is the data collection method, we can say the planimetric data as well as the. So now we are considering some of the methods to introduce you how to do the measurement of the depth. So first is lead line method. Here there is a graduated rope, and now with the help of some heavy weight, 5 to 10 kgs, I am suspending that at a position where my buoys are located. So buoys are there on the water surface which is floating. So I bring my boat there, stop there and try to suspend the lead line. So lead line having a heavy weight at the end, what will happen? It will keep on lowering down itself under its self weight, and when it touches the seabed or river bed, I will stop and I will measure the height. Since it is a graduated one and having a 0 mark on the bottom, what will happen? The point which is closer in my hand of the rope, it will indicate the depth of the water surface. Fine. That's a simple idea here. Okay. So it is also shown here in the figure. Now second is sounding pole method. So instead of rope, now I am using a sounding pole which is 5 to 8 meter length and it is having 5 to 10 centimeter diameter. Okay, what I am doing? I am again approaching the buoys. The moment I reaches to buoy at the XY location or at the position of buoys, I will just drop down a pole which is called sounding pole vertically down. Okay, I assume here that there is no water current, so water is still or it's very calm, and as a result whatever depth of the water is there, that will be indicated by the sounding pole. And sounding pole at the time of measurement, it touches the river bed or seabed. Fine. As I know that it is only 5 to 8 meter in height or length, we can conduct the hydrographic surveys with this sounding pole if the depths are in this order. Fine. So these are the idea, and the key point here is that the 0 point is always marked at the bottom where the sounding pole or the lead line touches the river bed. Okay, there is something called wire drag survey. In case of sea or in case of big water bodies, what happens? We have two vessels. Okay, let us see there is one vessel here and there is a water surface here, and let us say there is some water bed here. Fine. So let me just draw, this is water surface here, like, okay, now we have two vessels here and there is a wire being dragged, a stretch between the two here. Okay, on this wire what do? We have some buoys, okay, and then we try to suspend some heavy weights like this. These are my heavy weights here, okay, and again we suspend the another one here, like this, and they are also connected here in the down. Similarly, we do keep on doing this thing. Fine. Now let us say there is some obstruction like this here on the water surface. That means the river bed or the sea bed is like this. Fine. Okay, that is here. This is sea bed, and sea bed is here like this. What will happen the moment we suspend the wire here? It will happen, it will interact here at this less height. Fine. Now, as two ships moves, what will happen? The catenary or the straight length of the wire drag will be made like this, and there will be V shape here at this point. Now we can understand that there is some obstruction in the on the water, on the sea bed or river bed, right? So that's the idea here. So I can find out by putting this correction what is the seabed depth here, and so that's the idea called wire. That is the idea of the wire drag survey. Okay. So now we have the fathometers, or what we call echo sounders. Originally they are named fathometers, and nowadays we are using the term echo sounder. What it does, it basically sends some sound waves into water surface, and that sound waves interact with the surface of the seabed or the river bed, and it reflects back the energy of the sound, and again it is collected by the instrument. So by measuring the travel time, of to and fro distance, we measure the time of travel, and using that time of travel we determine the depth of the seabed or what river bed. Fine. So that is the idea of the fathometer. Then we have the echo sounders, as we told. Then we have the single beam echo sounder, which means it throws the sound pulses vertically down towards the surface. Okay. Then we have multi-beam echo sounders, which throws the pulses in across the track manner. Remember, like LIDAR, or in case of radar, we have the same mechanism, what we call a whisk broom mechanism. So according to whisk broom mechanism, if sea vessel is moving like that, so that multi-beam echo sounder is throwing the pulses in this direction, like this 1, 2, 3, 4, 5, 6, 7, and again as we move 1, 2, 3, 4, 5, 6, 7, and so on. So the multi-beam echo sounder is throwing the pulses towards the seabed, and it is acquiring the data in the zigzag fashion. Fine. Now let us look another method, airborne laser hydrography. We can see here that all the methods what we have discussed, like sounding pole, sounding line, the lead line, or the echo sounder, all of them are little time consuming because their coverage is very less. But at the same time we realize that there are some pulses like sound pulse or the laser pulse, they can penetrate through water, and as a result we are now want to use them. What if I use the airborne facility? That means there is a LIDAR sensor that is throwing the pulses towards the water surface, and as a result there are two types of pulses. One is red pulse here that is interacting with the surface of the water and it's reflected back. Okay. On the other hand, there is another type of pulse which is green pulse here, and that is penetrating the water, interacting with the river bed here and going back, right. It is reflecting also, but again it is reflected back and it is going back to the sensor. And by measuring the time interval of the green and the red pulses, I can find out what is the depth of my sea bed, and the coverage because of the airborne facility will be much higher compared to the echo sounder which is used with the vessels. Fine. That's the idea here about the measurement of the depth. So we will be discussing all this instrument in detail in coming lectures, but here we are giving just an introduction that how do we perform hydrographic survey and what is a hydrographic survey. So as we realize now that we need to collect the data by hydrographic survey, so first we should understand that it is a different kind of survey compared to the topographic survey, and so we have the different standards, and that's why we should first understand those standards, and then we should try to think that what is the quantity of work and what is the kind of work we need to conduct when we talk about hydrographic survey. Okay, so let's go ahead one by one. So we have two kind of standards. That means one is international standards that is decided by the International Hydrographic Organization, IHO, and that is basically governed by the International Hydrographic Bureau, IHB. Fine. And then we have the country specific standards. For example, India, there is a Bureau of Indian Standards. They have developed a code, IS code 4651, which discusses about the standards for India. At the same time, we have the Canadian Hydrographic Services. They are developed for the Canada. So now we are going to discuss about the IHO standards and the BIS standards in this lecture. We are discussing the country specific code. At the same time, we are discussing the provisions in the international standards. So let's talk about the IHO standards first. It divides basically the area to be surveyed, right, according to the importance. And so it has 4 orders. One is special order, then we have order 1, order 2 and order 3 surveys. Okay. So order 3 surveys are for the water depth more than 200 meter, order 2 for less than 200 meter, order 1 is less than 100 meter water depth. Again, it has some other specifications according to 100 meter, 200 meter and 300 meter. Fine. That means for 100 meter or order 1 survey, we have less hazardous bottom, more clearances, harbour and general intercoastal and inland navigation channels. Now, what about the special order? Okay, we define a term minimum under keel clearance. That means because of the weight of the vessel, what happens, vessel or ship submerges partly into the water surface. So, after submergence, from the bottom of my vessel to the riverbed, there should be some minimum distance, and that is called the mean under keel clearance. So, in case of special order survey, we try to determine what is the mean under keel clearance, is it available or not for a given water vessel or for a given ship under the some loading conditions, right. And hence here we say that we are looking for potentially hazardous bottom characteristics, whether there are shoals, whether there is some underwater permanent body at a given point or any other obstructions there. We should look for those things, and that is why we say that we should have the closely spaced survey lines, or we say that whatever we do, we should cover the 100% bottom search, and that is called the special order survey. I hope you got the idea now that why do we need a special order survey, order 1 survey, order 2 survey and order 3 survey for hydrographic survey practices. And this is the specifications of the International Hydrographic Organization. Let us go ahead. Now, what about the positioning? So, we want to discuss about the positioning also. Okay, we determine the sounding, which is nothing but depth. Okay, at the same time, we determine the XY position where we are determining the sounding position. Now, imagine that I am using a sounding instrument which is quite accurate, but if there is no accuracy of my sounding position XY, then there is no point of having the higher accuracy of the sounding instrument, and that is why we need to specify the accuracy of the horizontal positions also. Fine. So, that is why we define that the 95% probability that the 2 position should lie within the given accuracy level of horizontal position. Fine. Nowadays, in the latest version of IHO, they have specified that we should also consider the depth of the water, right, in order to define the horizontal accuracy. That means, if higher the depth, I can have some little tolerance on the horizontal accuracy of my position, and that is why they say that for special order there is no compromise. That means each and every point XY should be located within 2 meter accuracy. That means, and that is coming from 95% confidence interval. Fine. I hope that you got the idea, because we have already discussed these 95% criteria in my adjustment computations, or in the basic surveying they are dealt in detail. Okay. Next is order 1 survey. What is this? It is 5 meter plus 5% of the depth. That means, if my depth is, let us say, 40 meters, okay, now we say that the order 1 survey has to conduct for the depth below 100 meters. So, yes, 40 meter is appropriate for order 1 survey. Now, if you take the 5% of the 40 meter, that will be how much? 40 into 0.05, it is equal to, you can see here, okay. Then we can see like this, okay. So, now you can have 2 meter additional one. So, we have a 2 meter additional tolerance in case of order 1 survey. Similarly, we have 20 meter for order 2 survey, we have 20 meter plus 5% of the depth, and for order 3 we have 150 meter plus 5% of the depth. So, this is the way we calculate the possible accuracy level for a given depth of my string. Now, you can see here, if I measure the depth with high accuracy, I can comment that what is the tolerance of my planimetric position, or what is the tolerance of my accuracy of the planimetric position. Fine. Now, one more thing is there, that the depth accuracy. So, we just talked about the position accuracy. Now, we are talking about the depth accuracy. Again, we have defined the 95% confidence interval level, and both fixed errors, that is constant errors, and depth dependent errors should be included here. Okay. So, all these errors has to be included, and finally, how to determine the errors or the accuracy. So, it is a square plus b into d times whole square, where a is by depth independent or the constant error. So, if I make the sum of all the constant errors, which is equal to a here, and b is depth dependent error. So, d is my depth. So, I say that, remember we said in case of position error 5% of the depth. So, it is somehow b is like that factor. So, b into d, then we will make the square and we make the summation of the squares, and then we take the square root, and then we say that this is my depth accuracy. So, we should be very careful now in order to evaluate my depth accuracy of the sounding operations, right. Then if we have systematic errors and random errors, we should make the use of this formula. That means, this is my systematic error square, random error square, and then we use this RMSE logic. Okay, what about the line spacing? Fine. In case of special order, we have 100% bottom search, which is essential that whatever accuracy we maintain or whatever line spacing we maintain in case of special order survey, I have to have exploration of 100% bottom. That means, complete seabed or river bed has to be checked. In case of order 1, we have 3 times average depth or 25 meters. In case of order 2, we have 3 to 4 times of the average water depth or 200 meter. So, whichever is greater. And then we have order 3, which says 4 times of the water depth. So, here the line spacing has shown here, and it is wider line spacing here, you can see. So, these line spacings are decided according to this survey order criteria. Now, quality control. So, we should minimize systematic and random errors, that is my quality control. And then what is the quality assurance? I should validate my accuracies also, right. That is called the quality assurance here. Okay, coming to the Indian standards, which are governed by the Bureau of Indian Standards. So, the accuracy requirement here is according to the purpose of this survey. So, for the structural installations, dredge quantity estimation, we should have a special order survey, and special order survey are according to the IS standard, not the IHS standard. Please careful. Okay. So, then general planning, pipeline or route selection, we have order 2 survey, and then we have order 2 survey for the numerical model input purpose. Okay. So, how to decide the line spacing? For the single beam echo sounder purpose, for this structural installation here, we have 10 meter line spacing. Then we have for the pipeline route selection, we have 50 meter, and again for numerical model and input processes, we have 100 meter line spacing. Now, we should also prepare the hydrographic charts for the detailed planning, and in order to do the general planning, we should have a map of 1:50,000 with a contour interval of 20 meter. For the detailed planning, we should have a map scale of 1:5,000 or 1:2500 or 1:250 also, very high level map, but very high contour level also, 1 meter. Fine. So, the accuracy standards are to be followed as per the IHB publication SP 45, which is nothing but International Hydrographic Bureau. Okay. Then the spacing between the tie lines or the cross lines in traverse direction should not be more than 10 meter. Here is very special thing about the cross check lines. Be careful on this. And line spacing requires 100% overlap between the swath of adjacent path for multi-beam echo sounders. That means, if I am using a multi-beam echo sounder for very special purpose surveys, then I should have the complete coverage of my seabed. So, single beam echo sounder are to be considered for shallow water depth. That means, if water depth is less than 10 meter, I can use the single beam echo sounders. Now, in addition to that, the Indian standards also specify meteorological data, oceanic data, geological data, data to be collected as per this standard, then local resources and other informations. Okay, so once we collect the hydrographic data or by hydrographic survey, what do we do with data? We develop the nautical chart. So what is nautical chart? Okay, so nautical chart specifies obstructions in the water and channel markers, and it uses different colors and numbers. So we'll see these specifications now. Okay, let us see, this is my nautical chart. So the beach or 10 color here indicates the land masses or obstructions. Fine. So this is my land mass, or it could be the shoreline or some kind of land surface. So if we have dot with a teardrop, it indicates lighthouses like this. So this is the location of the lighthouse. Okay. Then we have white for deep water, and we have light blue for shoals or shallow water. So like this is my shoal, and this is the remaining white part is my deep water. Fine. So now you can see here shoals. Okay. Then we indicate numbers to indicate the water depths. So these are my numbers indicating the water depth here. Fine. So now you can see that here some depth of unit 13. Fine. Okay. What next? We have the unlighted green and red buoys, that is small diamond shapes of the appropriate color. So these are my small diamonds. That means the red is indicating the red color buoys and the green is indicating the green color buoys. Fine. Now we have the circle surrounding the buoy depicts that it is floating. That means if I draw the circles like that, it means that both green and the red buoys are floating on the surface of water. Then we have buoys like that, which we are showing with a color here, the filled color, filled circle. You see, they are indicating that they are flashing, they have some electricity light and they are flashing. Now we have some other features also like wrecks and sudden wrecks, and the symbols, other symbols like indicating danger to the navigation. So like this. So then we indicate rock awash, coral reefs which have unknown heights like this. And then there is another expression of the hydrographic survey data, which is hypsometric curve, especially for the sea. Okay, what is the hypsometric curve? It is the scientific way of describing the topography of the sea floor. Fine. It denotes the percentage of the earth's surface at various ranges of elevation. That means if I draw an elevation level, that how much area is above that level on the land as well as above the land in the sea. The cumulative hypsographic curve gives the percentage of the surface area from the highest peaks to the deepest depth of the sea, river, ocean bed. So this idea is kind of elevation curve it is giving me, and this is giving that where the sea depth and what is the depth, but it's very low scale curve. So the curve displays the elevation on y-axis and the vertical area above the corresponding elevation of x-axis. The curved line on the graph gives the different type of material present. Fine. Now this is an example that we have taken from the website of NOAA, and here we can see that this is the water here. So this curve is showing the surface level of the sea floor or on the land as well as under the sea. So this is my continental plain and this is my sea here. So here is my sea depth. Fine. Okay, that's my zero level. So as we go along here by unit of 10, 20, 30 and so on, I am having at this elevation level, for example, at 4000, minus 4000. So this is the water level and this is my sea level. So I am saying zero level, and again I am indicating what is the average ocean depth here. So this is my elevation level here. Now you can understand, and this is the cumulative area of earth surface on the. So as we are going in the x direction, the cumulative area is 10, 20, 30, 40 and so on, right. So what is the data available here? And here we are showing the histogram, that is what is the area here like this under this one water and so on. So that is what we call hypsometric curve. And what are these applications like isostasy, continental ocean crust? Basically they are related to the geological studies, but they also come from the hydrographic data, and that is why we say that we have two products, one is nautical chart and other is hypsometric curve. So, with this we say that we are now close to the end of our lecture 1, and that is the introduction and the fundamental concepts of a hydrographic survey. I hope that you could understand why do we do the hydrographic survey, what are the tides, what is low tide, high tide, what is the frequency of the tide, how tide varies, so how the attractive forces are accumulating the water on one surface or the one point on the surface of earth and creating the high tides and low tides at other places. Fine. With this we realize that how hydrographic surveys are very important for river as well as for the sea. In case of river we have the river navigation, in case of sea we have navigation as well as tide problem or tide phenomena. So, with this idea we also at the end we understand that what are the standards which are quite different from the topographic survey, and we should follow those standards, and they are comparatively quite different. Okay. So, after those standards we realize if we collect the data, we have two products that can be prepared. One is hypsometric curve and other is nautical charts. Fine. I hope you got the idea of the hydrographic survey. Here we would like to highlight that we have used these documents to prepare our lecture. At the same time, we have used some of the sources for our images, and with this I would like to say you thank you very much. In the next lecture we will be talking about the field procedures, that means how to collect the data in hydrographic survey. Thank you.